Alright, this is the last problem set in this SAT book that I've been working through, if you've been following along. So we're going to get some more practice on surface areas and volumes. Alright, let's begin. This might be a little longer because usually these problems take a little longer. This might be a longer video. Okay, so let's begin. The figure above shows a cube and a rectangular prism. The volume of the rectangular prism is 30 times the volume of the cube. What is the value of x? So let's write an equation first of what's going on. V of the prism, or rectangular prism, I'll say VR, equals 30 VC. Okay? How do we get the equation for any prism? By the way, a cube is a prism, it's just a special case. Area of the base times the height. So volume of the rectangular prism, area of the base, so 4x plus 3, 4x minus 3 times 2x, okay, equals 30, and this one is just x times x times x, so that'd be x cubed, okay? Now we go through solving for x, go through the motion of solving for x. There's a difference of 2 squares, that's 16x squared minus 9, times 2x is 30x cubed. Probably need to move all the x's to one side. Okay, so that's what I'm doing. So this is 32x cubed, right? 32x cubed minus 18x. Did I do that right? 32x cubed minus 18x is 30x cubed. Okay, so then this is 2x cubed is 18x. I can even, or maybe let me do minus 18x equals 0. Okay, so I can factor out a 2x, right? So then that would be x squared minus 9 is equal to 0. So 2x, I can factor that difference of 2 squares. So x can be 0, 3, or minus 3. We can't be 0 because you won't have a cube then. Can't be negative, it will be a negative late. So the answer must be 3. Okay? So you had to be good with the algebra there. Not that difficult though. Well, to me it's not difficult at all. The figure above shows a triangular prism whose base is an equilateral triangle with side lengths x and height square root 3 times x. If the volume of the prism is 81 over 4, what is the value of x? So volume 81 over 4 is volume of a prism, again, area of the base times the height. So what's the area of the base? What's the area of an equilateral triangle? There's a formula for it. Honestly, I never remember it, so we gotta derive it then if we don't remember it. So for equilateral triangle, this is 60 degrees over here. This is 30 degrees over there. This would bisect, so this is x over 2. This is x, right? So then this is, this height is x root 3 over 2. So area of the base is half times the base, which is x, times the height, which is x root 3 over 2, and then times the height, which is root 3 times x. Area of the base, these three, times the height, okay? So then 81 over 4 equals root 3 times root 3, that's just 3, and then x cubed on top, over 4 on the bottom, right? Okay, so then these 4's would cancel, and that, what's 81 divided by 3? That should be 27, right? 27 is x cubed, so x is 3. Again, so answer is A. Okay. A regular hexagonal prism with edge lengths of 2 inches is created by cutting out a metal cylinder whose radius is 2 inches and height is 4 inches. What is the volume of the waste generated by creating the hexagonal prism from the cylinder, rounded to the nearest cubic inch? So we probably want to find the volume, right? Yeah, volume of the whole cylinder. That's what you start with, minus volume of the hexagonal prism. That's what you want. So then that's what's left is the waste, the unused material. Okay? So volume of the cylinder is area of the base times height, pi r squared h. What is r? That is 2, so pi times 4 times 4, that is 16 pi. Height is 4. Okay, how about volume of the hexagonal prism? Area of the base times the height again. So how do we get the area of a regular hexagon? Well, we can use that formula, half the apothem times the perimeter, and then times the height. Okay, so what is the apothem? So for a hexagon, we can take one of the triangles inside the hexagon, like this one. Okay, the radius is 2. What's the measure of each angle? There's 360 total. Actually, not 360. The central angle is 360 total, divided by, how many triangles can we form? 6 triangles, so 360 divided by 6, that's 60. So this angle is 60. We're going to bisect it, because it's a isosceles triangle, so that's 30 over there. Okay, so that means this is a length of 1, and this is the length of root 3. The height is root 3. Do we need that, though? That is the apothem, exactly. So this is half times root 3. What's the perimeter? Well, it's 2, right? Is that right? 2? That's, for some reason, doesn't seem right to me. Okay, it looks to be right, so let's go with it. 2 times 6, that's 12. And what's the height of that hexagonal prism? 4. So this is, what is that, 48. Actually, this can cancel to 2, so 24 root 3. Okay, so therefore, we just do 16 pi minus 24 root 3. And you plug that into the calculator, that should be 8.696. So the answer is B. Okay. In the figure shown above, if all the water in the rectangular container is poured into the cylinder, the water level rises from H to H plus X inches. Which of the following is the best approximation for the value of X? Well, the water rises, so initially in the cylinder, there was this much water, okay? And then you pour this into here, you have that additional height of X now. So this, let me cover it with something. This cylinder right here, the volume of this cylinder must be equal to the volume of the sky. And just imagine you're pouring it into there. So the amount that you poured in, this additional amount that happened, is this amount over here. So volume is what I'm thinking that we have to use. What's the volume of this? It's 6 times 5 times 4, which is 30 times 4, which is 120, right? Okay, so that's the volume here. Now, how can we use that to our advantage here? What's the volume of this? It's, again, 120. By this, I meant this amount that we poured. Same amount of liquid, so 120 equals, what's the volume equation for this? This is a cylinder. So area of the base, so pi. What's the radius? It's 3 square, pi squared times the height, which is x. Okay, so x is 120 pi over 9. So if you plug that into your calculator, that's 4.244. So the answer is D. Okay. Moving along. The figure above shows 2 cylinders that are rolled up from a poster 36 cm wide and 50 cm long without overlap. For cylinder 1, the height is 36 cm and the circumference of the base is 50 cm. For cylinder 2, the height is 50, circumference of the base is 36. Which of the following is closest to the difference of volume between the 2 cylinders in cubic cm? Okay, so volume, again, area of the base times the height. So how can we use the circumference to our advantage? Well, circumference is 2 pi r, right? So radius is circumference over 2 pi. Oops, I got cut off. Circumference over 2 pi. So volume difference between the volume of two cylinders. So volume 1, let's do volume of cylinder 1, is pi. Radius is circumference over 2 pi. So 50 over 2 pi quantity squared times the height, which is 36. V2 is pi times 36 over 2 pi. Again, circumference over 2 pi is the radius. Squared times 50. Okay? So, volume 1, if you punch it into a calculator, that's 7161.972, something like that. Volume 2 is 5156.620, something like that. Take the difference. That is 2005. So the answer closest is C. Okay? So pretty simple. You just have to use, it's not directly giving you the radius, so you had to get the radius from the circumference. You just had one additional step. In the figure above, a double cone is inscribed in a cylinder whose radius is x and height is 2x. What is the volume of the space inside the cylinder but outside the double cone in terms of x? So, the way to go about this is, again, like we did before, find the volume of the whole cylinder minus find the volume of the two cones. The volume of two cones, okay? And you could probably safely assume that these two cones are symmetric, so you could just find the volume of 1 multiplied by 2. Okay? Did it say double cones? Yeah, it should be symmetric. Okay? So, how can we do this now? So, volume of the cylinder is pi times radius is x, x squared times height is 2x. What's the cylinder? Volume of the cone, let's say one of the cones, okay? How do we find the volume of a cone? It's 1/3 area of the base times the height, right? So it's 1/3 area of the base times the height. What's the height? This is 2x. If you safely assume symmetry, half is x then, times x. Okay, so that is 1/3 pi x cubed. Okay, so you're going to subtract these two now. Or you're going to double this and then subtract that with the double of this. So what is that? That is 2 pi x cubed minus 2 times 1/3 pi x cubed. Okay, which is equal to 2 pi x cubed minus 2/3 pi x cubed. Okay, so 2 minus 2/3, what is that? Well, 2 is the same thing as 6 over 3, so that is 4/3 pi x cubed. Answer C. Okay, oh, we're actually moving at a good pace. The surface area of a cube is 54 square centimeters. What is the volume of the cube in cubic centimeters? Okay, so what's the formula for the surface area of a cube? I don't have it memorized, but what's the area of one face of the cube? That is, let's say the cube has side x, okay? So it's x squared. How many faces are there in the cube? There's 6, like a dice, right? So 6x squared equals 54. X squared is 9. X is plus or minus 3. We're going to keep the positive only. Okay, because it's a lane. We don't want a negative lane. So volume of the cube would be x cubed, which is 27. Okay, yep, that's correct. A cone with a height of 10 cm and radius of 3 cm is 90% filled with shaved ice. What is the volume of the shaved ice to the nearest cubic centimeter? Okay, so we can find the volume of the whole cone and then just take 90% of it, right? So, what's the volume of the cone? That's 1/3 area of the base times the height. So pi, what's the radius? 3 squared times height, 10. That is 9 divided by 3, that's 3, so 30 pi. it's only 90% filled. So 30 pi times 9 over 10 equals 27 pi. Okay, so to the nearest cubic cm, so if we put this in the calculator, that's 84.823, so then round it up 85. Last one, a square pyramid and a cube have equal volumes. The cube has an edge length of 4 inches. Pyramid has a base side length of 6 inches. What's the height of the pyramid in inches? This is very similar to this one over here, but now there's two shapes. So cube, the volume is side cubed, right? Area to base times the height. So all the dimensions are the same, so that's why it's side cubed. So let's call the side x again. X cubed is the volume. They have the same volume, right? So let's just say x cubed is the volume. So 4 cubed is the volume. What's 4 cubed? That should be 64. All right. So then 4 cubed, or 64 is also the volume of the square pyramid. So for a pyramid, it's 1/3 area of the base. So the base is side length of 6 inches, so 6 squared, it's square. Okay, so area of a square is just the side squared, times the height, so that's what we're trying to find, h. Okay, so 64 equals 36 over 3 times h. This is just 12, right? So h is 64 over 12. Which is, what is that? That is 3, if I divide by 4, that is 16, right? That's the answer. All right, and that's it. Thank you for following along the series if you've been here from the beginning. I know that I skipped, if you have the book, I skipped the very early chapters, where it was just defining variables, writing expressions, and all that. I don't plan to go over those. But I did also skip over some of the quote-unquote chapter tests. Like this was a chapter test for some of the sections as well when I first started the series. Like the stats sections I never did, the word problem sections I never did. So I might go back to those if you're interested. But otherwise, thank you for, once again, if you followed along from the beginning or even if you followed along from the middle, I thank you for watching and for your support. Please like and subscribe if you found this helpful. Really helps out the channel and makes me motivated to make more videos like this.